Hi there, I'm Paketa12, and in this channel I present some of my methods of working with Touchdesigner. And for today we have this problem in which we would like to subdivide each edge of this polygon to achieve even distribution of points in that lines. So the first thing doing this, it might be I don't know, let's start from scratch, and we need a polygon, and we use a circle, um, and let's say 3 division for now. And obviously, being in 3D context, we might think that subdivide this will give us more points, and it's true. If we increase here by 3, let's chain a null here and see everything it's happening in this line. Okay, so let's see wire. Okay, now you notice subdivide will split each line in two, so the amount of points on each side will be power of 2. Sometimes when you go too high with this value here, you might get some serious drops in FPS, and let's try to delete the inside points, and we can do that by using delete. And since delete don't have the ability of selecting the edge, we use group here and go for edges and unshare edges, and we need to set here points. And now we have the contour we need, and we name it edges. Okay, and here in delete we delete anything else, points. Okay, now we have those nasty little corners here, you see, and we can get rid of them by using convert sop and choose points. And now we have nice points, but very bad order, and there are several ways of doing this in a correct manner, and I believe you can make it either in dots, in chops, in tops, or in sops also, even though here you can't find matte sop, so you might think that it's impossible to make some computations here, but instead we will try to rebuild it, right? So yeah, and about chops, I found lately this approach of Jean-François Renaud, which is a wonderful way of doing the same thing, going through chops. Okay, so let's start clean and do this first in SOP context and then in tops. And we need a constant chop. Okay, and here we need sides and divisions. Okay, and let's see a polygon. So we use circle sop, and for the division we go with sides. Let's set 3 for sides and 5 here, and okay, let's go with 3 sides, and let's see the points here. Okay, now what I want to do is use align sop, which have some nice feature of creating some points in between the point A and point B, so in a very nice order. So I think if I use 2 2 points here, 0 and 1, and rebuild this line with those coordinates, then I can subdivide it quite easily from here. So okay, let's do that. Okay, and I would like to have this line 0, 1 line being vertical. So first we use transform SOP for rotate this polygon on z-axis 360 divided by the number of sides multiplied by 2. So I believe it's minus, let's check. Okay, so we have minus here, and now our line 0, 1 is there no matter what how many sides we have. So our 0 line, it's where it should be. So we delete everything else. For that we use delete SOP, and we go for range and set okay from 2. Okay, and here we need points. So let's see what we got. Yeah, we got 2 points, right? And now we take them out, and I use a null in the end of this line here, and I use a SOP2 to take the points. I have 2 points here, only 2 samples, and I use shuffle to put them in different order. So split all samples and then reorder by numeric suffix sort. So now I have at the top I have the first point, and in the bottom the second point, and I use that for building my line here. So I'll take the first point, obviously t, z, it's 0, we leave it like that. Okay, now we only need to rotate this line, and we use copy, and okay, let's chain a null here and see the result. Okay, so let's see the points. Okay, and now I want to have number of copies as how many sides I have. Okay, and we rotate each one by on TZ by 360 divided by sides. So now I have that polygon, and I can have oh, we don't set here the divisions, so yeah, okay, now we good. So the order is it's perfect, right? So now let's do the same thing, but in a different manner. So we don't need this, right? Let's select the input polygon. Okay, and I want to see, since I have 4 points here, I want to see how a texture with those points it might look. So we go for chop, and here we go chop to RGB. Okay, so I have 4 pixels here. The last two are black since they might be on minus side of either x or y. Okay, and let's go for three sides since it's much easier to see if we do everything wrong or not. Okay, now I wanna make a very simple difference between point 0 and point 1, and that difference on tz and ty, if I divide it by the amount of division I want, I'll get a little step, let's say, an increment, and later on I want to form kind of a stair with that increment and the ramp that I will build. And yeah, that is the way. And for that, we need to make a difference between two textures, and would be nice to translate this to the left. So nearest, okay. We translate to the left by 1 pixel. And we said, okay, we want to repeat the tile. And now we subdivide this, okay. Now we subtract, sorry for that, okay. And now we have differences between the corners, and I want to split them in x and y. So I use reorder for that. And since this reorder will take only the red and it will be mono, right? But I would like to see it as x, and I will mark it by red color. So the other one will take green, and it will be green, okay. And now I have the xy distances, and I want to use a math to divide that by the amount of divisions. So let's use nearest, okay. And here I multiply by 1 divided by divisions. So then I would like to have a texture in a particular resolution, like the columns will be divisions and the rows will be corners. So I have to flip this bottom left, okay, and put it in a fit top by this resolution, okay. And we need exactly that for y values, okay. And now I would like to form that ramp we need. So in order to achieve the numbers between 0 and how many divisions we have, in this case I believe 5, no 8, and we can use a ramp, but since the ramp top doesn't give us the fully 0 or fully 1, we use parameter chop, and not parameter, we use pattern, okay. So I will choose a ramp here, and okay, let's say hold on the here and take the chop out, okay. Now I'm in between 0 and 1. Either I go here on amplitude and set a different value, or use a math here and multiply by divisions. Okay, and we also need this fit, and let's be sure in all the fits here we stay with the fill and nearest pixels. Okay, now if I multiply this ramp I build with tx values, also with ty values, okay, and I will take this texture as x values for my points and this one for y values, and to build that texture I use a reorder, and the first input take the red and the second input take the green, and now I need to set nearest pixels here, and notice the inputs is both of them are mono, and so my reorder OP takes that as default, but I will choose 32 here, and I'll force the Z to be 0. Okay, now obviously I have some points here, I can fill it, so let's use a null, right? And yeah, let's make a very simple instancing method by using top 2 out of here and take tx, ty, tz. We don't need alpha for now. Take full image and shuffle. Okay, shuffle channels by name. Okay, null. Okay, and now we will instance a sphere, and yeah, I want to make radius 0.5 and use a polygon and frequency by 3, and use a transform SOP to rescale this by, I don't know, this value, and geometry. Okay, and I'll take this chop, and now I have tx, ty, tz. Let's see a little bit bigger what we have now. So geometry viewer. Okay, so I have this, yeah, and this is because I subtract here the initial points, subtract from that translated texture. And what I need to do now is select the initial points like this, treat them to become in a resolution as those. So I use this fit here with the flip, and now I want to subtract this from the initial points. So yeah, I don't use alpha. Let's have nearest pixels. Okay, now we good. So we can have as many divisions we want, right? Okay, let's see, there are some points missing, the ends and the starts, so I will check to see what happened here, because yeah, okay, so this should be 0 here, the first one, because I'm on 0 here. Okay, let's see if, okay, now we good. Yeah, so this is the method, and yeah, let's see what if we have those points, right? So what can be done with this? So okay, let's increase the amount of the divisions by 1 to 8, right? Now we have a perfect line, and but I want to use a noise on those pixels, so I go here and use a noise stop. Okay, and this should be 32, and let's see what we have now. Okay, let's play with the noise. Okay, now you see the ends are not connected, right? So, and this is because our noise values are not actually on the points we have. We can achieve that by doing this, and now our corners are connected, and so yeah, we can play with this noise as we want now. Okay, and okay, let's make it move a little. So we use ABS time dot seconds. Okay, divided by 10, let's say. Okay, so we have those points now, and we can change here the polygon we have, right? So, and we can go quite high with this. Actually, you can go way above 1024, which is quite nice, and yeah, you can achieve very nice thing with this method. And yeah, this is the tutorial. And have you subscribed yet? Okay, then I will show you something else, something very little. So what we can do here in terms of having some variation is to use pixelate, and what this does here is will form kind of a clusters, because you see now I have a division 10 by 10, but my texture is 4 on height, and yeah, we go here like this, and now let's say we use 1 to 8. Okay, now we see we can form some kind of clusters, right? Because this is what Pixelate does. We have a kind of group of pixels with very, very similar values if our dry-wet mix is under one value. Okay, so yeah, this was my tutorial, and you can subscribe if you like it. And yeah, I plan to do this weekly, so see you in the next one. Bye.